So we're looking at page 46. Oh, it's question. It's section 1.4. I didn't write down the page number. Let's see. It's page 62, and this is in the second edition, 2.3. It's in section 2 or edition 2.3. And they could change in the future. So the question that we're looking at is this thing. But write a quadratic function whose fixed points are -2 and 3. And the one, so I'm gonna address this to the person who wrote this, but for future reference, I don't know, I'll make this video and we'll keep it. Yeah, I mean, what you did worked, and all that work was great. I'm trying to decide is are there other answers? That's what I was looking at. So let me get to my thinking. So what I did is I graphed, so I know if it's a fixed point, f of 3 has to equal 3, and we know that f of -2 has to be equal to -2. So then I made a little sketch here. And so let's see, so -2, -2, I know that point has to be on that parabola. And I know that this point has to be on the parabola. And then because parabolas are continuous and there's no broken, it's defined on all points, and I know it's got to pass through the y-axis. In calculus, we call that the intermediate value theorem. If the function's defined, and that's one reason why I'm making this video. I know if the function is defined here on this side of the y-axis and the function is defined on this side of the y-axis, and it's a continuous function like parabolas are, it's got to pass through that. Now it's a parabola, so I'm not going to do a line, but we want to make it be a parabola. It could be like this, it could be like this, it could be really shallow. It should, theory says, I mean, thinking about it, it really should say this. So here's what I did to prove this to myself. I know that these quadratic functions look like this: ax squared plus bx plus c. And then if f of 3 equals 3, 3 has to equal a times 3 squared, which is 9, plus b times 3 plus a constant. And then the other piece of it is that should be -2. -2 has to equal a times -2 squared plus b times -2 plus a constant. And that becomes what? So that becomes 3 equals 9a plus 3b plus c. And then -2 has to equal 4a minus 2b plus c. I don't know if you remember solving linear systems, and we're going to look at these again towards the end of the course. But this is algebra 1, so hopefully you remember that. This aspect of it is algebra 1. I've got 3 variables. I really need to have 3 equations to solve this. So I was at a loss for a little bit. So what I did was I said, well, hey, you found an equation. Your function that you found was here. I'm going to get rid of this. Let me clean this up a little bit. Okay, so you found in your equation, you wrote x squared. You wrote f of x equals x squared minus 6, and that certainly worked, and you showed that it worked. So then I said, well, what happens if 0, -6, which is the vertex of that equation, should work in this thing. So if I plugged in 0, if I plugged in go back to just a minute here. Back to that. If I go back to that original form and I plug in 0, I'm going to get -6 equals a times 0 squared plus b times 0 plus c. So that tells me c has to be equal to -6. And if I were to solve this equation, 3 equals 9 times a, or the system, 9a plus 3b minus 6, and -2 equals 4a minus 2b minus 6. That would bring this down to the equation, or down to the two equations. 9 equals 9a plus 3b, and 4 equals 4a minus 2b. And then let's see, because I brought the 6 over. If I'll solve this one, though it makes the video longer. Here, if we solve this, I'm going to use this by elimination. I'm going to multiply that top. I want to get rid of the b's since they're opposite signs. I'm going to multiply the top equation by 2, the bottom equation by negative 3 on both sides. I'm going to be, okay, I'll write it over here. 2 and negative 3. 2 and 3, sorry, I don't want to make change of signs because they're already positive and negative. So 18 equals 18a plus 6b, and 12 equals 12a minus 6b. Add those equations together, we're going to get 30 equals 30a, so a has to be equal to 1. And then to find b, we go back to one of these two equations right here, and I can drop in the a is 1, which means that's going to give me 18. I'm going to subtract 18. That'll tell me 0 equals 6b. b has to be 0, which corresponds to your x squared minus 6. So then I said, well, what happens since I know it's going to cross? I know I've kind of lost my graph here, but since I know that this parabola has to cross through that y-axis, I said, what if I use any point? I mean, we use negative 6. What if we use anything? So I wrote this. Let's see, where am I? I wrote this 0c, and I dropped in 0 into that into that ax plus bx plus c, and I got c equals c. Well, if this means it doesn't matter what c is, c can be anything. So I mean, it could be 0. It could be any real number. That's because we know it's got to go through the x-axis. So you could drop any c value you wanted into that, and you could create an equation of the function. It might be rational exponents. Just a minute. Let me do this. I'll do one of these out. I don't want to record all that. So probably nobody's going to be watching this video this far. But here's what I did. I said. Okay, I want to make this graph just to be different. I wanted this parabola to open down. So I said, let's pick the point 0, negative 10. So that meant my C is 10 now. Remember, I said C can be anything. So I dropped 10 in for C. And then what I did is I moved that over to get negative 7 and moved it over to get negative 12. And then I did the same math. I wanted to get rid of the B. So I multiplied top equation by 2, bottom equation by 3. Gave me this equation. I knocked out the b's, I solved for a, I got negative 5/3. Then I had to go back up here and without the multiplications I'm doing, and I replaced the a with negative 5/3. See, I did replace, and that's what I wrote. And I solved that for b, and I got 8/3. So that gave me this quadratic equation where there's the a, there's the b, and there's the 10 I arbitrarily picked. Then I substitute. Now I got to check to see if those fixed points work. I mean, it should, because I set those as a constant in the equation. And then, yeah, sure enough, it comes down to negative 12 plus 10 is negative 2. So f of negative 2 is negative 2, and I did the same thing with 3, and that also worked. So it doesn't really matter what c is in this case. So thanks for posting this.